In this video, I will explain the example problem in your book uh, because this example is little different from other conventional example. It is for a bundled bar. So the problem is example is 7.5. It is telling compute the development length required for the uncoated bundled bar shown in figure. If Y is 60,000 psi, F prime C 4,000 psi with normal weight concrete, and use the equation and assume KTR 0. Uh, if if you need to find KTR, you can also do that. If in your exam they asked calculate KTR, so hopefully you can do it also after this explanation. So again, in the equation, we saw that there are some factors, psi t, psi e, psi s, lambda, and all the factors are 1. How? Psi t is reinforcement location factor. If I go to the is case is given here. So why psi t is 1? Because it is a reinforcement location factor. If you have more than 12 inches of fresh concrete below the bar, then it is 1.3, but there is how many less than 2 inches of concrete here, so psi t should be 1. Why psi e is 1? Because there is no epoxy, it is uncoated bar, so psi e is also 1. Why psi s is 1? Because this bar is number 8 bar. We know that for number 7 or higher, psi s is 1. If it is number 6 or lower, then if it is then psi s is 0.6, sorry, 0.8. Why lambda is 1? Because it is not lightweight, it is normal weight concrete, so all these factors are 1. Then something else, we know that we need CB. CB is, you can remember, center of this bar to this side, or center of the bar to this side, or half of the center to center spacing, whatever is smaller, that is CB. So that is something different in this problem because it's 3 bar. What we will do here to calculate that CB, we will merge these 3 bars together and make it as a single fictitious bar. That is, they are doing it here. So area of 3 number 8 is 2.35. 3 number 8 bar, it will be 2.35 inch square. I know how you can do it, because 3, what is the area of number 8 bar? Area of number 8 bar is most probably uh, 0.1 sorry 0.79 times 3, 3.25 inch square. Then if I combine these 3 as a one bar, in that bar the diameter, say dbf, diameter of bar, if means fictitious means like not real. You can see the spelling here, fictitious is not real, it's imaginary bar. So pi d pi, oh, they wrote here is not pi d square by 4 equals 2.35. That means that is 1 bar, and that is the sum of the 3. Then they calculated the radius of the or diameter of the fictitious bar, 1 bar through like this way. Okay, now they are calculating the distance. So first is side cover. Side cover means here they are doing this way, horizontally. So if I make it bigger, what is the horizontal distance? So you can see this 2 inch is out of the tie. So this 2 inch plus this number 3 bar plus half of this, the center of this. Or if I zoom in, it is here. So in x-axis, the centroid is at the middle. That is clear. In y-axis, it is 0.79 dB. It is given. So for this one, for horizontal distance, 2 inch, that means this 2 inch plus this 3/8, that means the tie, plus 1 bar. The diameter of the number 8 bar is well, yeah, 1 inch. So total is 3.83. So this is in horizontal direction. Now we'll do it in vertical direction. What is that? Then 2 is plus this tie plus the centroid from here to somewhere here, that means here to here. So 0.79 bar diameter. They did the same thing, 2 inch tie, then vertical centroid, 0.79 times dB. Now this value is given in this problem, otherwise you will have to calculate it. But that will be very time consuming, because it's not so easy to calculate the centroid here, but not difficult, time consuming. Here our concern is not to judge you for the centroid. We are doing the reinforced concrete design, so it is given here. So the 2 plus the tie plus the vertical centroid is totally 3.16. And then what is the half of the center to center distance? So they found it here, half of the distance. This 2 means the half. And how the distance from here to here is this? Because you can see 10 is from out of the tie to out of the tie. Then 10 minus 2 tie, one tie here, one tie there. Then minus 1 bar here, 1 bar here, because the centroid of this is something at the middle. So they deducted this bar and this bar, that is 2 1 inch. Why 1 inch? Because it is number 8 bar. So divide by 2, this 2 came from the half, we got it 3.62. Now we should consider the smaller of this as a CB. That means the smallest is 3.16. So that is our CB. Okay, then everything else is like known. As they told us to use KTR 0, so they are not calculating KTR. So CB is 3.16. Now something to there's something twist here. In the bottom of this part, dB, it will be the fictitious bar, is not the real bar. So this is why they are using 1.73. But there's something else. The dB that we use here sometimes, that dB is actual dB. That is something confusing and something to remember. Okay, so they calculated this portion 1.83 less than 2.5. That means good. They will use this. Then they calculated using our equation. Now this dB sometimes we write here, sometimes we write there. So they calculated this 340 Fy lambda root square root F prime C psi T psi E psi S CB plus KTR over dBF. Again, something to remember, this dBF is the fictitious. This dB is actual bar number 8. Now after calculating, they got 39 times the diameter, because we place the diameter here. If you place it here, you can directly multiply. That is not a problem. So it is a bundle bar of 3, so we need to increase by 20%. If the bundle bar of 4, we increase by 33%. So dB by LD by dB is 39, 1.2, that means I am increasing 20%. That means 47 times diameter. Now they are multiplying the diameter. So in my last example, when I was solving it, I multiply the diameter here. But again, it's the same thing. It's like different people have different style. Then finally we got LD will be 47 inch. That is one is diameter is 1. So hopefully you understood how to calculate development length for bundle bar. Something to remember is CB is calculated based on a fictitious diameter, and in this portion the dBF is the diameter of the fictitious bar. Now, so the example is completed. If I want to expand this, how to calculate KTR? You know that KTR is, if you see the, can remember the equation, it is 40 times ATR divided by SN. Now what is area? If I go, so area will be number 3, 1, 2. So 1 is 0.11 times 2. That is the area. What is S? S is the center to center spacing of the tie, and that is not given here. So we cannot actually calculate. Uh, so this is how maybe they told us to assume KTR is 0. If they told us, okay, calculate KTR, then they would give that value, the spacing of the tie. Okay, so I could not expand the problem, but at least I explained that if it is given how to calculate KTR. KTR is 40 times ATR divided by SN. S means the spacing of this bar, N is the number of bar to be spliced. Okay, so I will stop here. In the next video, I'll solve another problem. Thank you.